Hello students, how are you? Hope you are healthy and safe. As we have completed our 3 units of our syllabus, now it's time to start our 4th unit, and name of the 4th unit is oscillators. As oscillators, the name suggests it is depend on the oscillatory motion. And what do you mean by oscillatory motion? Oscillatory motion means it is a repeated motion or to and fro motion, and it is going from one point which is minimum value and going to the other point which is maximum value. So the motion it will repeat after a certain time period, that is oscillatory motion. And same as the in case of oscillators are the device which produce undamped oscillations of desired frequency. Here the name undamped means the oscillations which has fixed amplitude with time, means the amplitude is not changing with the time t, or the damped oscillations means whose amplitude is changes with the time t. So in case of oscillators we are interested in undamped oscillations, or we can say that oscillators are the devices which convert DC power supply into the AC power supply without any supplying the input signal. That is the basic feature of the oscillators. Or in short, we can say that oscillators are the AC signal generators. We can divide the oscillators into two categories. One is sinusoidal oscillators, other is non-sinusoidal oscillators. Sinusoidal oscillators are those oscillators which produce the electrical oscillation in the form of sine wave. For example, tune-based oscillators, collector-based oscillators, etc. There are many types of sinusoidal oscillators. These are the two main categories. And second is non-sinusoidal oscillators. Non-sinusoidal oscillators are those oscillators which produce the oscillation in a non-sine waveform. Means note is the type of sine wave. It may be a type of square wave, sawtooth wave, triangular wave, etc. In case of non-sinusoidal oscillators, the main example of non-sinusoidal oscillators are multivibrators. That is not in our interest, means the multivibrators are studied in higher classes like MSS, where you study the multivibrators, and multivibrators are the example of non-sinusoidal oscillators. Here the requirement is only sinusoidal oscillator. So we discuss the sinusoidal oscillators in different categories, or we can divide the sinusoidal oscillators into different categories depending on the frequency range. And depending on the frequency range, we categorize the sinusoidal oscillators into 5 categories. 5 categories means we divide the oscillators. First oscillator is audio frequency oscillators, means audible range. The frequency is in the audible range, and audible range, as you all know, that the audible frequency range is 20 to 20 kilohertz. So the oscillations produced by the oscillators in the audible range are known as the audible frequency oscillators. Second is radio frequency oscillators, and you know the radio frequency range. What is the range of radio frequency? Range of radio frequency is 20 kilohertz to up to 100 kilohertz, and here we specify 30 kilohertz. So the oscillations produced by the oscillators in this radio range, that is radio frequency oscillators. Third is very high frequency oscillators. Very high frequency oscillators produce the oscillation in the sine form in the range of 30 kilohertz to 300 megahertz. And fourth category is UHF, means very high frequency oscillators. Very high frequency oscillators produce the oscillations in the very high frequency range, and this very high frequency range is 300 megahertz to 30 gigahertz. You know that what do you mean by 1 gigahertz? 1 gigahertz is 1 GH is equal to 1 into 10 to power 9 hertz. 1 gigahertz is equal to 1 into 10 to power 9 hertz. Okay, and our last oscillators is in the frequency ranges microwave oscillators, and microwave oscillators produce the oscillation in the frequency range 3 gigahertz to several gigahertz. So these are the different categories of oscillators which we can divide on the basis of frequency range. These are the oscillators of our interest, because mostly we study in the audio world or video world ranges. These are the different categories, and the main function of the oscillator is based on the oscillatory circuit, or we can say that tank circuit. What is the tank circuit or what is the oscillator circuit means? Tank circuit, both are the same name of this oscillator or tank circuit. It consists of a capacitor and the inductor, and capacitor and inductor, you all know that both are the energy storing devices, and both are the energy storing devices. So we can draw the tank circuit. How the tank circuit can be drawn? This is the parallel combination of capacitor and the inductor. Parallel combination means here is the capacitor, and capacitor consists of two plates. One is positive plate, other is negative plate. So this is the capacitor, and here is the inductor. Inductor consists of different coils, and both are connected in parallel combination through some key. Okay, this is the parallel combination of capacitor and the inductor, and both are the energy storing devices. This is the key. K, it is represented by K. When the key is open, capacitor is fully charged. Before the circuit is not completed, means key is open, then capacitor is fully charged by some DC which is not shown in the circuit. And once the key is closed, then capacitor start discharging. When capacitor starts discharging, there is a current flow in the circuit. There is a current flow in the circuit, and the current flow in the circuit, it is passes through this inductor. And when the current is passing through the inductor, is changed in the magnetic field in the inductor or magnetic energy in the inductor. We know that the energy stored in the inductor is in the form of magnetic energy, and energy stored in the capacitor is in the form of electric energy. Okay, capacitors store energy in the form of electric field, and inductor store energy in the form of magnetic field. So once the capacitor starts discharging, current is flowing through the circuit, and the current is set up in the circuit, changes the magnetic field. Or here we can also name the effect, that is self-inductance. Capacitor is placed here, so the capacitor play or on the basis of phenomena of self-inductance, it changes the current or changes the magnetic field energy in the inductor. Okay, when the current reaches to maximum value, then the magnetic energy is maximum. It means at this moment the capacitor is fully discharged and the energy of the inductor is maximum. This position, capacitor has zero energy, means electrostatic energy is zero and magnetic energy is maximum. When the magnetic energy is maximum, then again the same process will be started. This is again the capacitor, and here is the inductor. Again the means when this again current is flowing in this direction, means the capacitor is inductor is losing energy, capacitor is again start charge. But what is the difference of this charging of this capacitor? In this figure we shown positive plate upside, negative plate downside, means the capacitor is again charged but with opposite polarity. This figure shown that the capacitor is charged with opposite polarity. In this way the process is going on, means the capacitor is again charged, here the position, capacitor stored maximum energy, inductor stored minimum energy. So the process is going on, the charging or discharging of the capacitor is going through this inductor in the circuit. This phenomena is responsible for the production of oscillations in the circuit, which is our requirement. And how we calculate what is the frequency of this oscillations produced by this tank circuit? We can calculate this frequency produced by this circuit. We can calculate this frequency as already I said that the capacitor stored the energy in the form of electric field. So total energy is equal to Q square by 2C, or Q is the charge of the capacitor, C is the capacitance of the capacitor. when charge Q is going through the capacitor in a time t, it will changes the current. So, and what is the energy in inductor? That energy in inductor is 1 by 2 L into I square. Here I is the current, L is the inductor. This is the total energy in this tank circuit. And one point I didn't explain earlier, there is no loss in the capacitor because complete energy of the capacitor is changing to the complete energy in the inductor. So there is no loss in the circuit, and because of no loss in the circuit, there is no change in the total energy in the circuit. There is no change in the total energy of the circuit. So how we can calculate this change? We can calculate this change du by dt is equal to, we can differentiate this equation, 2q into dq by 2c, same 1 by 2 2 li di by dt. ओके, टू कैंसिल, सब कैंसिल करके आपके पास जो इक्वेशन आएगी, एंड वी कैन पुट आई इज इक्वल टू डी क्यू बाई डी टी सॉरी, बाय दिस पुटिंग दिस इक्वेशन हेयर we can calculate the complete equation q into d of q into dq by dt into divided by c plus L into d by dt into dq by dt. Okay, this is the total energy change, and this total energy change is zero in case of this tank circuit. So by solving this equation, we can make this arrangement: d square dq by dt square plus 1 by LC into dq by dt is equal to 0. So we get second order equation. What is this second order equation? This is the second order equation: d square dq by dt square plus 1 by LC into q is equal to 0. This is your second order equation, and this is the solution of simple harmonic motion. And what is the solution of this equation? Q is equal to q naught into sine of omega t, and here omega is the frequency of this oscillation. What is this frequency? This is by the solution of the simple harmonic motion. This is the frequency. And what is the relation between this? Is the angular frequency, and angular frequency is equal to 2 pi nu. Where is the nu? Nu is equal to 1 by 2 pi 1 by LC. This is the frequency of this oscillator circuit, and the frequency of the oscillator circuit, this is the frequency. And because as I already said that there is no loss in the oscillator circuit, but this is not the possible case. This is the ideal condition, but in case of oscillators, this ideal condition cannot be fulfilled because in the inductor there is some resistance, and due to some resistance there is a loss or resistive type of losses, and in case of capacitor there is a dielectric losses. So some type of losses are there in case of tank circuits, and representation of this oscillations are, and what is the maximum value? Maximum value of current is I naught plus, and my minimum value of I naught is this, and these are the type of oscillations. These are the type of oscillations. What we observe from this figure means amplitude is need not to be remain constant with the time t. Here is the time t. You already see in the figure that amplitude is not constant with the time t. The amplitude is going to be decreased with time t. So what type of these oscillations are? These oscillations are not undamped oscillations, which is our requirement. So what we can do? Is that we have to fulfill some conditions for obtaining the undamped oscillations. Undamped oscillations produce करने के लिए, और for the purpose of fulfilling the undamped oscillation. Type of undamped oscillations means I can draw a diagram of undamped oscillations. These are the undamped oscillations. These are the damped because oscillations are going to be decreased. These are the, I not mixing, I not meaning this time T. These are the damped oscillations. For fulfilling the condition or obtaining the damped or undamped oscillations, we have to put some conditions on the oscillators, and these conditions are, first condition is we have to apply some energy to the oscillators, or some energy is in the form of which can or look or rate this radiative losses. And second, the energy supply must be as in same phase as that of the frequency of the oscillator. Means the phase of the frequency of the oscillators is same as that of the energy supply by any other source. And third, the energy supplied must be in a proper phase so that it help in keeping the amplitude constant. So these are the three conditions. First condition is some energy must be supplied to the oscillators to compensate the loss of energy, to compensate the losses. Second, the energy must be supplied in the same frequency as that of the oscillator of the tank circuit. And third is energy supply must be in the proper phase so that it help in keeping the amplitude constant. Okay, this is the video representing the oscillators in types and the tank circuit, which is the basic requirement of our oscillators. So students, watch this video and it help to understand the oscillators up to some limit. Okay, thank you.